Okay, let me try to take a stab at answering this question. Oh, actually, for viewers, I'll just go ahead and show the question here. It said, can someone help me find the best predicted and then blank for homework 10.3? And I'm assuming you mean best predicted whatever, IQ, best predicted height, and best predicted things. And that's using these lines of regression that we've created. So I will answer this question by doing two problems from section 10.3, number 3 and number 2, and I'm intentionally doing it in that order. Because if all things go well, there's a prediction line that we can use, and they've already worked it out in this question. They had the data that we don't have, but they've summarized all of it so we can just get to the root of this one issue between these two problems. And here's the issue. When you're finding the best predicted values, you've got to make sure that the requirements are satisfied, and you take a different path depending on which requirements are or are not satisfied. So that's what they're getting at here, and that may have been where you got stopped up. So let me go ahead and go to the PowerPoint slides. But this is actually these are just the images of the slides. So if you want to check out the animated slides, go ahead and go to the multimedia page, download it there, and so on. So the strategy for predicting values of y, is the regression equation a good model? Well, that depends on whether or not you first plotted the data, which we don't have, and it had some sort of a linear pattern, and then you created this regression line, and it fits that pattern well. Okay, and then also if R indicates that there is a linear correlation. Now that's important. That's like running a hypothesis test where you're essentially assuming that there is no correlation, and that becomes your null, and your claim is, and which it becomes your alternative statement. Your claim is that there is some sort of correlation. Well, if we reject the null, then we will be supporting the claim in that case, and the claim would be that there is some sort of correlation. So what we do, the fast way to do that, and I'll just go ahead and click on this. This is also on several of your pages that are approved for notes. In fact, I'll just quickly flick through those. This is the formula page. Okay, so I have table A6 here, the formula and tables, where it does remind you how to find these equations for the regression line, but it doesn't tell you the concept pieces behind it that you need to remember. If you want some of those, there are some more of those in the Triola Stats Review. Again, one of the approved notes, where it gives you some information here like if no linear correlation is found, the best predicted y, the best predicted value for the dependent y is y bar. And remember, that's our bar notation that we've been typically using. So that would mean it was the mean, the sample mean from the y values, from the y coordinates of the paired data. If there is a linear correlation, then use the prediction line that's found by doing all that other stuff and plug in x. So anyways, that little page right there, or that little snippet right there on the review sheet, tells you a little bit more than the formula pages, and essentially tells you what this flowchart's telling you. If if one of these things doesn't fit, and in that case it was saying if there is no correlation, then you're going to use the mean of the y coordinates, mean of the outputs. Okay, so let me go back into this. If R indicates that there is a linear correlation, okay, so I said I was going to go to this table. You're essentially treating it like a hypothesis test. I'm restating what I just said about 5 minutes ago. So you're going to assume that there is no correlation, that rho is 0, and then you're going to test the null, but your claim is going to be that there is some sort of correlation, right? So this isn't saying how strong one way or the other, it's saying that there is a correlation and that rho is either less than 0 or greater than 0. Okay, we will reject null if the absolute value of R, and again absolute value, so even if our number here had been negative 2.07, we would just be looking at 0.207. is greater than the critical value in the table. And here's the table. This is the table A6 on those other pages. Well, how big was our sample size? It was 80. Okay, so scroll down here to 80. And then there's two columns. If the significance level is 5%, you've got to beat 0.220. And if the significance level was 1%, we've got to beat 0.286. We can't be equal to it, we've got to be bigger than that. And our value, our linear correlation coefficient is 0.207. It is not bigger, right? So let me come back up here. It's not bigger than 0.220. And we are going to be using 5%. That's why I'm staying in that column. So what does that mean? That means even though we have the regression line right here, we're not going to use it. We're just going to find the mean of the y values. So the mean of the output values, or the dependent variable. There's several names for it. In fact, all those names are summarized in the book and in your PowerPoints. So the responsible variable is another name for it. Alright, so I'm going to take y bar. Did they give it to me? They had to have, because they didn't give me the actual data. So the mean of 80 heights is blah. The mean of 80 pulse rates, that's what we want. Because what we're trying to predict is the pulse rate, right? Is 73.7. So 73.7 would be our best possible, our best point estimate. It's just the mean of the y values. And you look through all this and you think, you didn't even use this regression line that someone took all the time to figure out, or some technology spent all the computing power to figure out. Yeah, I know you didn't. Let me come back here. Because if the R value it doesn't indicate that there's a linear correlation, and in our case it failed because it was below the level that needed to be the critical value, which was 0.220. And so in essence we didn't have enough information to reject the null. The null is that there is no correlation, and if we couldn't reject the null, there wasn't enough evidence to support the claim that there was correlation. So if any three of these points fail, the last one was the prediction is not much beyond the scope of the available data. So if we're trying to make a prediction that's way out there, then again we won't be able to use this model. Look at my other video, by the way, for the first one, because we did one where the curve, where the scatter plot was a curve and it wasn't a line, and in which case you wouldn't be wanting to predict. You'd be wanting to predict with the mean, and you wouldn't want to be using the regression line. All right, let's go ahead and finish with homework question 2. I said I was going to do these backward. So in this case, you can pause and read the question. I'm just going to slide right through it. So there were 20 people. The R value is 89.2. Let me just show you that that's definitely high enough. Here are 20 people, and we need to beat 44.4% if you're thinking about it like that, but you're not. You're thinking of it as the alpha level, and then you've got to beat 0.561. Well, that was if we were being strict and only having a 1% significance level, or type 1 error, and we are not. We're actually going to allow, we're going to allow 5%. So we're way above. We're double that. Okay, so then if the original data is linear, which we get to assume because they didn't give us the original data, and they're asking us to do this stuff. If the prediction isn't too far off, and it isn't, they're asking us to go from, okay, I guess that one again we're going to kind of assume because we don't have the original data to see how far off this prediction would be. But either way, we're going to be able to use this prediction equation and just plug it in. So we've got 1.02 times what's our x value? 106 plus negative 2.44. And we get 105.68. So I did it in reverse order because I wanted you to see that it could be the case that we can't even use the model. That was number 3. In this case, we just use the model. That's assuming all requirements are met. And I'll just go back here. There's your flow of understanding. You can use the model if requirements are met. You can't if they're not.